Good morning, good afternoon, good evening, everybody, and welcome back to I&E's CCI Data Center Advanced Technology Series. In today's session, we're going to continue where we left off last with booting the UCS B-Series blades to the storage area network. We're going to look at a case where we already have an OS installed on the SAN array, and then what that would look like from the keyboard, video, mouse, the KVM console of the UCSM, and then we'll talk about what are the options for doing the installation of the OS onto the SAN, because normally when you provision the disk, it's going to be blank. And we'll talk about the difference between the object storage types, the file, or the block level storage types like Fiber Channel, FCOE, iSCSI, and then also the different ways that we can mount the installers either through the vMedia policy, through the SIMC, or with the KVM console for a manual installation. So before we continue, I want to just review real quick where we are up to this point in terms of our topology. So let's take a look at our network diagram. And what we have up to this point is that the UCS fabric interconnects, we did the basic initialization on them, so we gave them the default admin user password, we gave it the IP address of the individual FIs, we also gave it the virtual IP address for the cluster. Then we acknowledged the chassis. The way we did that is we specified interfaces E1/1 to 2 were configured as server ports, which behind the scenes again means that they're running as FEX fabric. Because again, the fabric interconnect, you can think of this like the 5K, it's the top of the rack switch, and then the I/O module that's physically inside of the UCS blade chassis is like the fabric extender that's ultimately connecting down to the end servers, which are the B-Series blades. So we have connectivity from the FIs to the servers. We saw that during the chassis discovery policy, that the UCS manager learns about what are the individual part numbers of the servers that the chassis has in. And then we modified some of the Ethernet interfaces and changed those to fiber channel, so the unified ports. And we saw that the result of that requires a reboot on both of the FIs. And so now we're ready to finish both our LAN connectivity and SAN connectivity, boot up the server, get it onto the network, do some testing of basic layer 2 reachability. And then beyond that, we'll talk about the LAN connectivity designs once we have a couple servers actually up and booted. Okay, so next let's go back to the UCS manager. So let's go to our jump box. And I want to show what the status of the currently defined service profile is that we have. And we talked about the service profile being the logical configuration of the physical server. And recall that the service profiles are going to be assigned on a one-to-one basis to the physical machines. So if we have a UCS blade chassis that has 8 physical blades, it means in order to boot all of them up, we would have to have 8 different service profiles. But we'll see a little bit later, we can define templates in UCS and also clone service profiles. So once we have a working configuration, both from LAN connectivity and SAN connectivity, we can basically just make copies over and over and over and then continue to use those for our other servers. Okay, so we can see at this point, we have the KVM console open. And the server is now booted into VMware ESXi. And I did have a problem in the last section with the storage area network. Basically, the particular volume that was mounted on the SAN wasn't actually activated. So I had to just go into the storage array, turn it on. And then the end result is that the blade recognizes the remote fiber channel storage as if it was a directly attached disk. Okay, so what I want to do first is to reboot the server and then show what the basic boot process looks like, and then how we can tell whether we do have storage connectivity to the storage array in order to actually mount the disks for the SAN. So to start, we're under the Equipment tab. Under Equipment, I'm going down under the individual chassis. Okay, so you'll see that in the UCS manager, there's these. There should be here on the right. Let me move this over. And I may need to refresh the window. Sometimes you'll see that the HTML5 page doesn't render 100% correctly. If it has a problem, just refresh the page. Or if for some reason it's giving you trouble, you can also use the Java interface. But what normally should be at the top here is a plus or minus button that would collapse all of these, the object browser that we have open. But what I'm going to do is just close some of these manually. So let's go over to chassis. I'm going to close up chassis 1 and then close up the fabric interconnects. So what we're basically looking at now is the service profile was defined under servers. So under servers, under all, we have service profiles. Under the root org, okay, the organization structure we'll talk about a little bit later, we have a profile. The profile has two storage ports, which we call the virtual HBAs, the virtual host bus adapters. And those are going to be to mount either fiber channel storage or FCOE storage. And then we also have the virtual NICs, the VNICs, which are going to be the regular Ethernet interfaces that we're sending our normal IPv4, IPv6 traffic down to the servers on. So as part of the profile related to storage, the most important piece of the puzzle here that we have defined is that each of the storage adapters has what we call a port worldwide name, or a WWPN, or a PWWN. This specific number, you can think of it like a MAC address from an Ethernet point of view. It's basically the layer 2 addressing for fiber channel. But what's important about this is that this exact number is going to be matched on the storage array in a configuration that's called the LUN mask, or the logical unit number, the LUN mask. It's basically like an access list to make sure that the servers are mounting the correct volume of storage. But the key point here is that in a real deployment, there has to be some communication from the UCS management team, whether that's the network team or the server team, to the storage team, because this variable is going to need to be manually programmed in to the storage array. So at the end of the day, it doesn't really matter what this number is, this 200025B5 number. It's just that whatever that variable X is, it has to match on the UCS side is the source address for the initiator. Okay, so basically where the storage traffic is coming from. It's going to match on the storage network side in the zone set, which is like an access list for the storage network. And then it also has to match on the LUN mask of the array in order to make sure that this particular server is mapped to a piece of physical storage or a piece of logical storage, like a slice out of a RAID 10 array, a RAID 5, RAID 6 array, etc. Okay, but in my particular case, this number is manually programmed in the SAN. That's a step that I had done previously when I was provisioning the individual disks on the array. Okay, we also see that it's assigned to a virtual SAN. Okay, the virtual SAN here, it doesn't tell us what number it is, but if we were to go under the SAN tab and then find this particular variable name, FCVSAN, it would tell us on Fabric A versus Fabric B what particular actual number that we're using. Okay, so this is going to be not under the storage tab, but under the SAN tab. And then under the SAN tab and then under vSANs, we'll see that there's two different places that you can define this. You can define it globally for both fabric interconnects at the same time, or in this case, I have the vSANs defined separately for Fabric A versus Fabric B, but notice that they have the same name. They're both capital FC underscore vSAN, but they're mapped to numbers 101 on Fabric A and mapped to number 102 on Fabric B. So you'll see that with the UCS system, what it generally does not allow you to do is to rename objects. In most cases, you have to delete the object and then recreate it. But what it will allow you to do is change what the mapping is behind the scenes. So for a vSAN, this would be the mapping of the vSAN number to the FCOE VLAN. And then in the VLAN case, we can change the mapping of the name of the VLAN to whatever VLAN number that we're using. Okay, so just a point being here is that sometimes it doesn't show you the actual numerical value, but we can see that we do have it, two different segments, 101 on A, 101 or 102 on the B fabric. Now from the network connectivity point of view, we have the native fiber channel interfaces that are going up to the 5 case. Okay, so in this case, we have interface FC1 31 to 32 on Fabric A and 31 to 32 on Fabric B. So if we were to go to the command line of the UCS, so here I'm logged into the console, okay, so username admin, and then from the CLI, we're going to say connect NXOS, and from here, we're just going to look at the show interface brief. Now, what we should see first, since we moved the interfaces from Ethernet to fiber channel, we should see the FC interfaces. And in this particular case, we have FC1/31 to 32. We can see they're assigned to vSAN number 101. And then what's most important about this is that the operational mode is set to node proxy. This means that the interface is actually up and functional. So if you think of this like in the Catalyst world, where you can have an interface running dynamic desirable or dynamic auto, which is the administrative mode of the interface, basically how you have it configured, then the operational mode might be trunk or it might be static access, depending on how the link actually negotiates. The same case is true here with storage. So over on the left here under the admin mode, this is what the port is configured as for node proxy. Means that we're running the feature NPV, okay, for fiber channel end host mode. But just because you have it configured as NP doesn't mean that it actually is going to initialize as that. What we're looking for here is the operational mode. So on the other end of this link, so this is on Fabric Interconnect A, this is physically plugged into 5K1. On 5K1, when we look at the show interface brief, we should see that those two interfaces, which were 46 and 47 from the 5K's point of view, we have them configured as auto mode admin, and the operational mode is F for Fabric. So since we were doing auto negotiation, the end result was Fabric, which is going towards the initiator or the target. This tells us that the link is actually up. Okay, the next verification we would want to go through is the show floggy database from the northbound storage switch. In this case, it's a 5K. And this should tell us what the layer 2 port worldwide names are that the UCS Fabric Interconnect is logging in as. So let's look at the show floggy database. We see that on interfaces 46 and 47, we have these numbers, the 201F and the 2020. These ones belong to the Fabric Interconnect themselves. The way that we can also see this is by looking at the show FCNS database for the fiber channel name server. And in the type or the features, we should see that the FI, the Fabric Interconnect, is advertising that it is a node port virtualizer. Now, in addition to that, we see the actual initiator. The initiator is going to be the port worldwide name of the virtual HBA that I have configured inside of the service profile. So recall that previous screen under the UCS Manager, we went to the server tab, and then we went under the service profile. Service profile was called Brian_Pro_1. We went to the virtual HBA, which is called FC0, and then we see the WWPN, or the worldwide port name. This number specifically is the one that we see logged in to the 5K. So it tells us here that from a basic layer 1, layer 2 storage connectivity point of view, that the Fabric Interconnects do have correct reachability up towards the northbound storage network. Now also recall what we talked about previously in terms of the difference between the A fabric and the B fabric. The cluster link between them, the L1 and L2 ports, that's only for synchronizing the config. It's not for synchronizing the control plane, it's not for synchronizing the data plane. So what this means from an operational point of view is that just because your storage port is working on the A fabric doesn't necessarily mean that it's going to be working on the B fabric. So any configuration, any verification that we do, generally we have to do this twice. Once for FIA, once for FIB. So if we go over here to the second port, which is FC1, FC1 should be configured on Fabric B. Let's see, do I have a dialog here? No, so you can see sometimes the GUI is slow to respond. So now we're on interface FC1. This has a unique worldwide port name, and what I'm concerned about here mostly is the last 3 bytes, which are 1, B as in Brian, 1100. This ideally is pinned to the B fabric, so not ideally, it is pinned to the B fabric, which means Fabric Interconnect B, but ideally from the northbound switch point of view, which in our particular case is 5K2, we should be able to go to 5K2 and then look at the show floggy database, and then we should see this particular number, which is the 200025B51B1100. We should see this logged in through a Fabric login onto the northbound switch. And again, what this is telling us is that there is direct layer 2 connectivity between the Fabric Interconnects and the northbound SAN switches. Okay, so now we're ready to actually boot the OS. Okay, so let's power cycle the box. So we're going to go to the KVM console, and then additionally under the UCS Manager, we're going to go to the physical blade. So notice on the KVM console, it says that this is chassis number 1, server 5. So this is going to be 1/5 from a blade naming point of view. So this means that we're going to go under the equipment tab. We're going to go under chassis 1. And then we're going to open up chassis 1 and then go down to server 5. And under server 5, we should see that the service profile, which in this case is Brian_profile1, that this profile is currently associated. Okay, overall status is okay. So let's go ahead and click on reset, which is going to power cycle the server. Okay, it asks us, do you want to do this? Yes. Then it asks you, do you want to gracefully restart the OS? This would be like going to Windows and saying restart, or saying reboot from the Linux CLI, so it's like a graceful shutdown. In this particular case, I'm just going to power it off. Okay, it's the same as pressing the reset button physically on the server, or physically powering it off, powering it back on. Okay, so we see right now status is restart. Now, additionally on the 5Ks, what I'm going to be doing northbound, okay, so on 5K1 and 5K2, we're going to go to global config, let's say logging monitor 7, logging level for fabric login, or logging level floggy is going to be at level 7, and then terminal monitor. Okay, what we should see is that when the storage driver runs in the BIOS, and we'll be able to see this from the KVM, it's going to say VIC FC boot driver. We should see that we get a syslog message from the 5K's point of view that the storage port worldwide names have requested a fabric login, and then ultimately that the northbound switches grant that, and what they're assigning is a fiber channel ID, the FC ID, which we talked about previously is synonymous to the IP address. So it's kind of like a DHCP request, where in the Ethernet world, you give the DHCP server your MAC address, DHCP server replies back with an IP address, and then we have a binding between the two. In the case of Fiber Channel, this is the Fiber Channel Name Server, or the FCNS database, that is going to be mapping the binding of the port worldwide name to the Fiber Channel ID, so like the MAC address to the IP. So we can see here from 5K2's point of view, it says that we got a fabric login. It came in on port 1/46. So if we look at this from the physical diagram point of view, 1/46 is one of the southbound ports from 5K2 facing towards the fabric interconnect. Then likewise, we should have got a similar log message on 5K1 that says we were logged into port 146 as well. Okay, then if we go back to the KVM, we should see now that the server is going to start to boot its OS. Okay, so basically what this is showing is that we have correct SAN connectivity between the fabric interconnects, southbound to the blades, and then from the fabric interconnects northbound to the 5Ks, and from the 5Ks to the storage array. The next thing we're going to do is we're going to make a copy of this service profile. We're going to change the worldwide port names. We're going to associate the new profile to a new blade, and then we're going to go through the install process to show as if the disk was blank on the storage array, how do we actually get the OS onto it. Okay, so first step I'm going to do is go under the server tab, and then we're going to make a copy, make a clone of the service profile. So specifically, we're going to go under server tab. We're going to right click the profile that I have, so Brian Profile 1, and we're going to create a clone. Okay, the clone is going to be in the root organization. Okay, we'll talk about the org structure later. This has to do with authorization for multi-tenancy. And I'll say that this is going to be Brian _ profile _ 2. Okay, create a new clone. Now, if we look inside of the individual profile, what we'll see is that a bunch of the variables that need to be assigned to the service profile are not filled in, because they have to be unique, or certain things at least have to be unique on a per profile basis. Mainly this is going to be the universe of the unique identifier, the UUID, any of the MAC addresses for the Ethernet interfaces, any of the port worldwide names for the storage ports, the node worldwide name for the actual physical adapter, and then the IP address that we're using for KVM management. Now, the IP address for KVM management, we don't need to assign, because I had created a pool under the LAN pools that was for management. Those auto get assigned to the SIMC interface, basically like the out-of-band management interface of the blade. And from our point of view, we don't really care what the IP address is. As long as you can ping it from your management station, or as long as you can ping it from the UCS manager, then we should be able to have IP connectivity. But the other variables, the UUID, the MAC address, the port worldwide names, and the node worldwide name, we'll see that I'm going to need to change these on this copy of the service profile, because we can't have duplicate addressing in the UCS domain. So same as like IP addresses, you need to have unique IPs in order to send traffic. Okay, so we're on profile number 2, and then let's go down to change UUID. Okay, right now it says that it's using the hardware default, where in this particular case, the hardware doesn't actually have an address, it's just a blank field. So we'll see that if we went to assign this profile, the service profile, or go through what we call association, So we associate the profile to a physical server. It's going to give us an error message saying you can't do that because these particular variables are missing. Okay, one of these is going to be the UUID. So to see that, what we could do is let's cancel out of here. And under the service profile, so we're under profile 2. Okay, the HTML5 shows the first one highlighted, but this is basically just a bug in the UI. So we're under profile 2, and we're going to change the service profile association. Okay, so this is how you assign it to a server. So we could either choose a server pool, which could be like a dynamic assignment, or we could just manually pick a number. So I'm going to say select an existing server, and let's say we just let's choose server or whatever, number 3. Okay, so server number 3, and okay. And it says that this is going to cause a configuration failure. The failure reason is that there's not enough resources. We cannot derive the MAC address from the virtualized port, and we cannot derive the worldwide port name from the virtualized port. What this is talking about is the physical network adapter that's inside of the blade. Now, there's different models, of course, for the adapter, same as like just regular network cards. Some of them come with these addresses pre-assigned. The Cisco cards, which are the virtual interface cards, the VICs, like VIC 1240, 1280, 1340, 1380, these come essentially blank. And then through the service profile, we need to flash or essentially program these variables onto the card when we associate the service profile. So it's basically saying that if you were to boot the server, the Ethernet interface doesn't have a MAC address, so it's not going to be able to send any traffic. Now, there's a couple of different ways that we can solve this. We could create a pool of addresses and then let the profile dynamically pull addresses from the pool, or we could do a manual assignment. Now, in this particular example, the values that I don't care about are the UUID, the MAC address, and the node worldwide name. As long as they have variables, that's all that I'm really concerned about. But the port worldwide name, since that value is statically matched on the storage array itself in the LUN mask, it means that I'm going to have to choose what particular number that I'm using for that. Okay, so otherwise, I'm going to create some pools for the resources. So here we're going to cancel the assignment, okay, because it said we're going to have an error. And what we're going to do is first we're going to go under LAN, and then under all the way at the bottom under LAN pools. Okay, so you can either scroll down to pools, or just at the top you can click the drop down and then select pools. So under LAN pools, we're going to go under the MAC address pool, and then we're going to go under the default MAC address pool. Okay, next we're going to create a block of MAC addresses. So it starts with Cisco's vendor code, so we can leave that as the default. Okay, the first 3 bytes, 0025B5, and then we're going to give it some range. Let's say we give it 256 addresses. In hex, this would be from 00 to FF. Okay, so we created the pool. It says right now there's 256 that are in the pool, and 2 of them have already been assigned. So if we look at under MAC addresses, and then it's going to show us a big table here of what the actual addresses are. So I'm going to click on assign. This is going to sort it by which ones are already assigned. Okay, so I want to sort it by which ones are assigned, so double click it again. And it says these 2 values, which are 01 and 02, these are assigned to service profile Brian profile 1. So these were the ones that in the previous example I had manually defined onto the service profile, or manually assigned onto the virtual NICs. So the system knows that even though that I had not created a pool in that previous example, that I can't reassign these addresses again because they're already allocated to one of the profiles. So even if you do a manual assignment that includes an address in a pool, the system automatically does a reservation for it to make sure that it's not dynamically reassigned to someone else that's in the same UCS domain. Okay, so we have the pool. Next thing we're going to do is to apply the pool. So we're going to go under servers. Under the service profile, we're going to go under the virtual NICs. So vNICs ETH0, so our first Ethernet port. We're going to change the MAC address, and then we're going to say that we want to use the default pool. Okay, and you can see the default pool currently has 254 addresses available. So this will be automatically assigned from the selected pool. Click OK, we can see it got an address. Okay, it ends in 8F. Same thing we're going to do for ETH0 or ETH1, vNIC ETH1. So change the MAC address, click the drop down, we're going to select the pool, and then click OK, and we should see that this now gets an assignment. Okay, the same thing is going to be true for the UUIDs and then also the node worldwide names. So we're going to go to server pools, we're going to go to UUID suffix pool, pool default, and we're going to go to UUID blocks, and we're going to add a block. Okay, so basically just adding a block of addresses. So this green plus should be somewhere on the screen. Sometimes it's on the right, sometimes it's on the bottom. So click on add. And let's say we're going to add 256 addresses, so from 00 to FF, so it's in hex. And actually, it doesn't let me do that. So let's say 1 and size of 255, so that'll be 01 through FF. And then the suffix we need to create in order to, or actually the prefix we need to create. And actually, it does this automatically. Okay, so it's going to take this kind of pseudo-random number that it generated, this 4A1585, etc., and then it's going to append the suffix onto the end of it. The end result is that it's going to give us a unique value. Okay, so in this pool, we're going to then go back to equipment, under servers, and then under service profiles. So click the drop-down service profiles, profile Brian 2. We're going to then change the UUID, and UUID we're now going to use the default pool. Okay, so we have 255 addresses available, and then the end result of this, we see now that it has a unique identifier. Okay, next one we're going to go under SAN, and then under SAN pools, we're going to create a worldwide node name pool. So we're going to go to the default pool, which already exists, and right now we have 0 addresses assigned, so we're going to create a block of initiators. So at the bottom, click on the green plus. We'll say we have 256 addresses total, so they start from 00, and then this is Cisco's vendor code. So the first 1, 2, 3, 4, 5 bytes are Cisco's OUI, and then the last 1, 2, 3 is going to be up to us. Now, the size of this, generally when you create the pools, you have to have some foresight and planning as to what the overall domain is going to be doing. But these numbers, you only need 1 per service profile, which essentially means 1 per physical blade or for each physical rack mount server, which means that as long as we don't have more than 256 physical servers, then we have enough addresses in the pool. Now, at a later time, if we run out of addresses, let's say we go to 1,000 servers, then the only thing we need to do is just come back and add more addresses to the default pool, and then they should be automatically assigned to those profiles, assuming that the profile is configured to use the default pool. So a little bit later when we look at templates, it'll make more sense why you would create all of these pools in advance to kind of save yourself time in the long run so you don't have to do manual assignments. Okay, so then let's go back to servers. We'll go to service profile, profile number 2. Then we're going to go to the HBA. Okay, so virtual HBAs, and we're going to change the worldwide node name. Okay, right now it says pool derived, but there's no pool assigned, so it doesn't actually have a value. So we'll change the worldwide node name, and then we're going to use the default pool. Okay, should have 255 addresses enabled or available. One of them was for the other profile, and then we should see now it's going to pick a value. Okay, so it picked 8F. Very last step is that I need to manually assign the ports to have worldwide port names. So I clicked on FC0. I'm going to say I'm going to do a manual assignment. And then this manual assignment here is coming from a list that I have on the actual storage array that is going to be based on the individual server number. Okay, so again, typically there's one of two ways you do this in a production design. You either create the number from the UCS side and then give it to the storage admin, or the storage admin creates the number and then gives it to the UCS admin. Either way, whatever this number is, it needs to match on both sides. Okay, so in my particular case, the storage array is just a Linux box. So what I'm going to do is to log into that box and show you guys what the LUN mask actually looks like. Okay, so let me get to the CLI here. And then the LUN mask in this case is stored under a file that is scst.conf. Okay, so let's just cat the file. So in here, basically what this is showing is these are the source addresses, the initiators, so where the traffic is coming from. Then there's going to be the target address, which is the physical port of the storage array. Okay, somewhere in here, you can see the LUN mask is pretty big. So let's say, instead of catting this, let's say more. And so somewhere down here, we should see the target value, which is right here. Okay, the target value. This is going to be the destination address that we would put inside the boot policy of the UCS service profile in order to say basically what's the layer 2 address of the storage array. Okay, it's kind of like doing MAC address to MAC address communication manually, but in our particular case, behind the scenes, there's going to be a mapping to the fiber channel IDs, and then the fiber channel IDs will be used to actually route the packets back and forth. Okay, so if we look at the 5Ks and then look at the show floggy database, this is going to tell me what physical port on the SAN that I have to use. Specifically in this case, it is this number here. Okay, it's on port number 48. So essentially what I need to do is look through the LUN mask, find this particular target, and then under the target, look at the initiators that are in the LUN mask for that. Okay, so I'm going to copy this string, and then let's go back to the Linux CLI, and then I'm going to just edit the file in VI. So let's say vi scst.conf, then colon slash the string. That's how you do a find in VI. Okay, so here's the target, and then what I want to do is pick one of the unique volumes, which in this case I'm going to say is volume, let's say volume 10. Okay, so this is going to be for an install for blade number 10 ESXi. Okay, the naming convention here doesn't matter. It's just that it has a logical unit masking set up, and we should see that we're going to be presented with two different volumes when the storage mounts. LUN 0 is going to be the boot volume. It looks like a physical disk from the service point of view. And then LUN 1 is where we're going to store our virtual machines, like the Windows VMs, the Linux VMs that are actually running on the hypervisor host. So it's going to mount those as two different physical disks, even though behind the scenes in the storage array, it's all one physical array, and then we're chopping it up into smaller volumes based on how we're defining the RAID set and then how we're defining the actual LUN mask for the servers. Okay, but the key here is that basically I just want to copy and paste this number, and I'm going to copy this and paste it into the port worldwide name of the service profile. Okay, so I'm going to do manual assignment and then just paste this number in. Let me try Control V. Sometimes the HTML5 interface has issues with this. Let me try Shift Insert. I may need to just manually type this in. Let me see if I can do Shift Insert. No. Okay, well, we got to manually type it. All right, so it is going to be 2000, okay, which it already starts with 20. Okay, so it's 20000025 B5 2A2200. Okay, from the UCS point of view, it's not case sensitive. Okay, so here's the value 200025 B5 2A2200, and I'm going to copy this again. Okay, this is on the A fabric, and then I'm also going to edit the one that is on the B fabric. I know that these values are derivatives of each other because I actually programmed them in, and what the second one should read is 2B. That's how I'm denoting from the storage array point of view. This A or B says, is it the A fabric or the B fabric? And then the rest of the number matches, which means it's mounting the same volume. Okay, but again, this number is arbitrary. It's just a variable. It has to be matched manually on the storage array side in order to bind the two of them together. Okay, so I'm not just making up this value. It's something that I had already programmed in the previous step. Okay, so now we're ready to actually do the association. So we're going to right-click the server again. So yes, I want to save my changes. Actually, no. It says, do you want to discard? No, I don't want to discard my changes. I want to save changes. Okay, changes are saved. And then we're going to go to the profile and then change the association. Okay, we're going to select an existing server, and then let's say we choose slot number 4. Okay, it doesn't really matter what blade we're choosing. Okay, it is now going to cause an immediate reboot of the service profile. Yes, I do want to apply it. Okay, let's now go back to under the service profile, under General, let's go to the KVM console, and then we should be able to see the actual association process happening, which is essentially the blade powering up. There's a lightweight Linux image that the UCS manager is going to launch, and this is used to program the variables, like the MAC address, the port worldwide name, the node worldwide name. It's going to run through that. It's going to have to reboot a couple times, and then once those values are actually programmed in, we should see that after a while it reboots one final time, and it should be then trying to mount its storage onto the storage area network. So notice here that when you click the KVM console, there's a bunch of boxes that you have to confirm. So make sure once you click on it that you keep this, whatever window you have in front, because if you miss one of those questions where it says, do you want to confirm, the KVM times out and then you have to start it again. Okay, so now it's booting. So let's go back to the 5Ks. And what I'm going to do here is just leave this logging running. Leave the 5K in front, and then what we should see is a new syslog message. When the boot driver runs, the blade should do a fabric login, which is it trying to assign a fiber channel ID to its port worldwide names, again like a DHCP type request. Then the fabric interconnect should proxy these requests up to the 5Ks. The 5Ks should then respond with the actual fiber channel ID, and then we see here from 5K1 it got a log message saying that the port was actually logged in. Okay, so if we now, from the 5K's point of view, look at the show Floggy database, we should see this new port worldwide name, the 2A2200. We see it logged in on one of the local interfaces. So port 147, that's one of the links that goes from 5K1 down to the Fabric Interconnect. Okay, and the same should be true on Fabric B. Then on 5K2, we got a new login on virtual SAN number 102. This came in on port 147 with this particular port worldwide name. We assigned it this logical fiber channel ID. So again, this is like mapping the IP address to the MAC address. It's the layer 2 to layer 3 resolution. And specifically here in this case, if we look at the show Floggy database, we should see the number of logins change from 4 to 5. And then the actual device we have logged in is this one here, okay, the 2B2200. Okay, now we see on the blade itself, so on the KVM console of the server, it says that we failed to find a bootable device. Okay, the reason why is that the disk doesn't have any OS on it. The server still sees it as attached though. Okay, it's the same as taking like a SAS disk or a SATA disk and then physically plugging it into your desktop. Once you plug it in, you have to put some OS on it in order for it to actually run. Okay, so that's basically where we are now, is that the server is booted, but the disks are blank. Okay, next step is that we have to do the actual install of the OS.